Hey guys, so here I have some boiling water, or it's about to be boiling water, and I have two different substances. The red substance here, well, I'm not going to tell you what the substances are right now. I want you to make some guesses, some educated guesses, but we're talking about something called thermal expansion today. So every substance has an expansion rate, meaning things expand when they get warm, or they contract when they get cold. And you're about to watch another one of those cheesy Eureka videos discussing thermal expansion and contraction. So when you think of thermal, you need to think of heat, okay? Here I have a hot plate, which is a heat source providing energy to the system. And as we add energy to the system, those particles inside each substance start to move faster and faster. They're given more kinetic energy, or that energy of motion between each other. So as they start to move faster and faster, they're starting to spread apart. And that's what causes this expansion. So notice very quickly, we're starting to see the red substance is expanding through this tube. Okay, we already can see the effect of thermal expansion. And here we notice the blue is also starting to expand, but not quite as quickly. So let's just keep watching this for a bit. I know it's very riveting science here, but we're going to make us some observations. So I want you to think about the rate of expansion. So how quickly these substances are expanding. Looks like the red one is expanding a lot faster than the blue one, but we do see that the blue is expanding. So that's important to note. In the video you're getting ready to watch, you will see that all substances have a rate of thermal expansion, even solids. This is how we get the idea of our thermometer. We use the fact that things expand when they get warm. So there's amount of mercury or alcohol in that thermometer, and it will rise a certain amount. And it also has to do with density. So we can see this blue is expanding a little more and more, but it's moving at a very slow rate. It has a slow thermal expansion rate. So if I were to tell you one of these substances is ethanol, and one of the substances is water, thinking about the density, ethanol has a density of, let's see, we can probably Google that. Ethanol density. Okay, ethanol has a density of 0.789 grams per milliliter. And water, or you should know at this point, has a density of 1 gram per milliliter. So in your notes that you're taking today, I would like you to describe how density is related to thermal expansion. Why did the ethanol, being less dense, have a greater thermal expansion rate? Think about how the particles are shaped. And if you can draw a particle diagram showing those particles, then that's even better. Okay, we want to show that a substance that is less dense is going to have, they're going to already be farther apart. So as you increase that heat, those particles start moving faster and faster. They have more space for that motion, so they expand even quicker. Imagine you are well, I don't want to talk about that just yet. So just pay attention to those rates, and you can't really tell. This ethanol is probably going to take some time to come back down, but as it begins to cool, well, I think some spilled actually there, but as it begins to cool, that ethanol will all go back down in that tube. So let me just get this out of the way. All right.